Myself, Dr. Ragaseshan, I'm a scientist working here. I'll be comparing the session for you all. And we have an eminent speaker for this day 4 session, Dr. B. Seshagiri Rao, who's joined ISRO in 1976 at Satish Dhawan Space Center and is retired as distinguished scientist on 31st January 2015. He served as Professor Satish Dhawan at ISRO from 2015 to 2018, and he has given various talks on space sciences, computers and real-time systems, radar systems, cloud computing, digital signal processing, Internet of Things, AI and expert systems, robotics and humanoids, smart systems, mobile communications, data processing techniques and special algorithms, and mini, micro and nano satellites, which you'll all be hearing soon about Sir's wonderful work. And Sir has published more than 60 papers in various international and national journals and guided many PhD and MSc students. He has received various awards during his career, and it was in 2014 facilitated by the government of Kerala as a member of Mangalyaan team. You all are aware of the Mangalyaan success by the government of India on October 2014, and he has received Lifetime Achievement Award in 2014 in Science and Technology at the Arunai Engineering College, Tirunmalai. So with these few words, I request Dr. Uday, I also request Dr. Uday Kumar sir, Scientist G, Director Grade, to please welcome Dr. Seshagiri sir onto the dais. I request Dr. Uday Kumar sir to facilitate the guest with okay. Today's theme is Swadeshi, Paramparik, Inventions and Innovations. India has launched many satellites and is the leader in this field. And we are now the eagle's eye of the world, and I think because of scientists such as Sir, we are here as the leader of science and space technology. In this regard, I request Sir to give his talk.
Good morning to all of you. Welcome to the Science Day celebrations. And let me know that how many of you are from 8th to 10th? A very large number. Okay, how many of the participants are from 11th to 12th? Okay, how many? Okay, there are. How many are from 6th to 8th? Good.
Sir, we have invited only 8 and above.
Okay. I could see some
Maybe few.
6 to 8. Okay. How many of you have seen yesterday one-day match? I'm surprised to see very few. Okay. So, you know how that stream has reached you. Anyway, some details you will see now. So you are all familiar with Telugu? Yes. You have to adjust any resolution? Otherwise, can you put mine? System. No, all slides may require better resolution, otherwise it will get overwhelmed submitted like this. Otherwise take my thing. Possible? Okay. But if your display system supports HDMI.
Everything is fine.
Okay, leave it there. Leave it there. Doesn't matter. No, they can understand. Leave it there. You would like to listen to the proceedings in Telugu or English? That's good. But any audio of Telugu is okay? Okay. So, let me congratulate the organizers here for organizing 1 week long Science Day festival, which is special to this organization. And as far as the 4th day is concerned, we are learning about Swadeshi, Paramparik, Inventions and Innovations. When you read this kind of a theme, do you feel that you can recollect or remember some institutes which are well known and excelled in research? Anyway, let me tell some of them. You have the ICMR, you have CSIR labs, you have DRDO, you have DAE, you have ECL in Hyderabad, many things. So the entire talk, you will go in listing them rather than let us say looking at it what it is. ISRO is also one among them, and they did lot of Swadeshi Paramparik innovations and inventions, such that we are second to none in this area. So you are knowing about these details? Some of them, yes. Okay. The other theme what is given here is the Vigyan, Sarvatra, Pujyate. So this is the very catchy information. The reason is this particular quotation is from Bhartrhari in Sanskrit. It is Vidwan Sarvatra Pujyate. Here there is a poem here.
నిగూఢగుప్తమగుణిత్తము రూపము పౌరుషాళికిం విద్య యశస్సు బోధకరి విద్య గురుండు విదేశ బంధుడు విద్య విశిష్ట దైవతము విద్య కుసాటి ధనంబులేదిలన్ విద్య నృపాల పూజితం విద్య నిరుంగణివాడు మధ్యుడే.
If you don't know science,
విద్య నిగూఢగుప్తమగుణిత్తం.
if you don't know science as an education, you are not a human. Is it true? Yes. The benefits of such education, science education is listed here. You get everything. If you want to know what is that everything, Vidya Yosagunu Vinayam, you get to know how to behave in society. Vinayam will give you, the Vinayam nanu badayu patrata. Patrata means you get a stature, you get a career. Such a respect will give you a career. What the career will give you? Career will give you the money. What do you do with money? you have to follow dharma. What do you get after following dharma? Aihika Sukambul. You get the entire happiness. That is the advantage of knowing education and science. But always, when you utilize such sciences, the benefits of science, you have to use viveka. That is, where exactly you have to use such things, you have to apply carefully, so that your study of education should not lead to your dangerous areas. Anyway, those things you will come to know the moment you become an expert in a particular area of science. The moment space you remember, you get immediately somebody talks about space. You remember how the sky will look like, how the moon is, how the stars are, when the sun rises, when the sun sets, it is of that type. But everybody has got a curiosity to know how they are formed, from where they have come. Is it like that? They are generated on their own? And are we the only people who are living here? Or are there any similar solar systems elsewhere? If you want to know something about the universe, let me put a few slides to get you a glance of the universe. Look at this. The universe, which is shown here, this particular portion, it appears like this. The moment you go through a telescope like Hubble, what is the extent of this? If you remember, you will sometimes know. Imagine what is the extent of this universe. It is 27 billion light years. What is a light year?
27 billion.
What is a light year?
27 billion light years.
The light travels at a speed of? The light travels at a speed of 3 lakh kilometers per second. All of you agree? Yes. 3 lakh kilometers per second multiplied by 60 will give you 1 minute. Multiplied by 60 will give you 1 hour. Multiplied by 24 will give you? Multiplied by 365? 1 year. How much is that? So anyway, there is a calculation I will show you. Okay? So it is 27 billion light years. That is the extent of universe. It can be multiverse or whatever it is. You see the other side. See, the moment you get into that pictures, what the scientists will do? Let us categorize. Let us categorize. Let us categorize them into clusters. Big cluster, small cluster, and a cluster associated with our galaxy. Let us limit ourselves to a cluster which is where our solar system is a part of it. Okay? Now you look at it. Quite familiar. See, this is the earth here. Its diameter is 12,700 kilometers. If somebody travels by car around the circumference in the equator at 100 kilometers per hour, he will non-stop. No food, okay, no break anywhere. It takes 17 days. Whereas, if I travel by speed of light, I take 0.13 seconds. So 0.13 multiplied by 3 lakh is the circumference. Do you agree with me? Yes. Okay. Then you see, we are all actually sun-centric system. Okay. The sun is 1 million Earth size. Okay, how much it is? 1 million Earth size. And the distance is 150 million kilometers. 150 million kilometers. So here afterwards, if I want to say a distance between a planet, I will say 1 AU, astronautical unit. 1 astronautical unit is 150 million kilometers. Okay, because every time to tell 150 million kilometers, like I told, speed of light you keep on multiplying, it will be like that. It is very difficult. Okay, here afterwards let us measure the distance between planets and other systems by astronautical unit. Okay, you know astronaut unit now. So for the present we will stop here. And anyway 1.39 million kilometers is the diameter of the sun. So these details are sufficient for you. Let us see next. You see here, we are in a galaxy, that is a Milky Way. We are a part of this. What is the total length of this? It is 160,000 light years. How much it is? 160,000 light years. What is the thickness of this? 1000 light years. Is it a small? Very big. How many such things are there? Billions. So in such the case, we are at some part here, somewhere here. Okay? The sun is located at the edge of the spiral. This is the Milky Way spiral at 30,000 light years from the center. It is not 30,000 kilometers. It is 30,000 light years from the center. Okay? And there are over 100 billion stars in the Milky Way. What is the star in our solar system? So how many are there in our Milky Way? 100 billion stars. So 100 billion stars means, that means wherever there is a star, if some planet goes around such a star and it has got an atmosphere, you can expect some life, isn't it? Yes. If such a planet is found, it is called exoplanet. Till now, few thousands of exoplanets are listed, but nobody knew whether there is a life. Okay? This is what, if you want to know the extent of it. Okay, you see how it moves. This is the simulated movement. Okay? Let us look at this one. Earth is rotating from on its own, isn't it? It spins, rotating west to east. At what speed? You look here. It is 16. If you are in equator, one single rotation takes how much time? Louder. 24 hours. That is by a day. Okay? So in 24 hours, unless it moves at equator 1670 kilometers per hour, you cannot complete 24 hours. The same thing, if you are at this latitude and if you are at poles, the speed matters. Okay? That is why I have put this slide for you is, if I am somewhere here, like a bus, you are traveling in a bus, I don't know at what speed it is traveling, but if the driver doesn't halt the bus, if I try to get down from the bus, what will happen? You will have that much speed when you are thrown out, isn't it? Similarly, any object that is lifting out of the equator will automatically have 1670 kilometers per hour if you travel towards east. Whereas if you are thrown out, when you want to travel west, you have to oppose that. That it is going to be useful for rocketry. I will tell you why it is later. And you can see that how nicely the moon is rotating around the earth and the entire thing is moving around the sun. Let us stop there. And all of you know this. So there is a sun in the middle and all planets are, what is this? What is the other one that side? Is it a sun or something else? Everything? See, all of us feel the moment Earth makes one revolution around the sun, you tend to believe that you are coming back to the same place after 365 days. Do you agree? You are supposed to come. You are making a production. After production, you are supposed to come back to the place where I am started. But if the sun is moving, for example, sun is also traveling at some speed. What will happen? The earth is moving around the sun because of its gravity. When sun is moving, what will happen? Will it complete the circle? No, it is a helical. You see, actual scenario is this. All planets, sun is moving, all planets are also moving. So the entire solar system is moving. Okay, that means the moment I spoke one word, our earth is not here. We are in the space somewhere. Okay? That is why I kept these two for you. This is once again to remind you the distances from the sun, each planet. See, you see here 9.5 astronomical units, 19.2, 30.1. It is for you to see later and know what it is. You see this one. So there are some things. I am talking about this one. The earth, it takes 1 year to go around the sun. The Mars, it will take 2 years. The rest of things anyway, you can read it. So these two, let us have some discussion later. Okay, this is what I am talking about. You have seen the earth is rotating on its own. It's moving around the sun. Sun is also moving. Sun is a part of galaxy. Galaxy is also moving. Galaxy is in a cluster. Cluster is also moving. Where are we going? What are the speeds? So you look at this, some of things I have listed here. Earth is rotating at 0.5 km per second. Earth moves around the sun 30 kilometers per second. Per second, please remember, it is not hour. Okay? And the entire solar system is moving at 230 kilometers per second. And the entire galaxies, clusters, all those things, anywhere between 40 kilometers to 600 kilometers per second. Suppose if all are moving in the same direction, if you add up, how much it comes? 900 kilometers. Is it believable? 900 kilometers per second. Where are we? Any object you have seen is moving at, what is the speed of the aeroplane? 800 to 1000 kilometers per hour. Isn't it? This is per second. So that means, people who say that I am stationary here, I am sitting on a chair, I am not moving, it is relative to you. It is relative to you. So that is why, to get you to the information related to the speeds at which we are moving, our galaxies are moving, solar system is moving, this slide for you. See, this is the calculation. 1 light year equal to 10 trillion kilometers, correct? Whatever I asked, I have multiplied. I know it is, unless you use calculator, you won't come. It is 10 trillion kilometers. Let us say, tomorrow somebody says to you, we have seen in our galaxy, there are 10 billion stars. Some scientists have told you, one star has got Earth-like system. If that is the case, can we travel there? So what is the nearest star we should find out? What is the nearest star? Proxima Centauri. What is the distance? 4.2 light years. Okay. Let us say, and there is another galaxy. If you want Andromeda galaxy, it is 2.5 million light years. If you want to go to the next galaxy, forget about that. First, let us see 4.2 light years. See, let us say forget 4.2 light years. I will give 1 light year to you. Somebody told you it is fantastic Earth-like system is there. You can enjoy better than this. So can you go there, which is 1 light year away? So 1 light year at the speed of 30 kilometers per second, 3 lakhs, there is a similarity. That is why I put 30 here. If you are traveling at 30 kilometers per second, okay, 1 light year, a star which is away from 1 light year, how many years you require? Otherwise, I will put how many generations on Earth has to change. See, this is the calculation, this is for you. Go home and see. If you say that 1 light year away star to reach so many generations, what will we know even later also about the universe? We will only know by pictures. We will send Hubble telescope, try to understand whether anything is decipherable and scientifically observable. Can you give some scientific logic for that? Whereas, if you want to reach, still it is yet to be dreamt of. Okay? This is for you. For example, there is a probe launched for that probe, they are launched from Earth in 2006. In 2025, which is about 50 astronautical units, to travel that distance, it has taken 19 years. It is going to take 19 years to go away from the entire solar system. This is one of the things related to Voyager 1 and 2. And similarly, if you want to go to Mars, 500 days. Okay, we'll come back to that. So this is how the distances, everybody will feel, there is a fantastic space research is going on. Later, if an aeroplane kind of a thing comes, I can go and travel anywhere. No, these are the distances. Okay? Okay, this is what Hubble telescope has given. I said so many galaxies, so many clusters can be seen. This is one thing. So you see here there are 3 circles. 2016, there are small observations related to a Chota galaxy. And 2019, all 3 disappeared. We don't know what has happened. First of all, what are those things? Why it disappeared? So currently, in addition to Hubble telescope, they have launched James Webb. How many of you heard of James Webb? Good. So that is going to be positioned at Trishanku point, Lagrangian point, okay, which is 15 lakh kilometers away, and they are going to measure the observe the universe from that place. Anyway, we will discuss if some opportunity comes later. Okay, let us come to the exploration here. Space exploration, as I said, space exploration is the best example under this title, Swadeshi, Paramparik. So you look at here, ISRO is concerned, these are all the material is available to you, they have actually 12 spacecraft missions, 82 launch missions, and 12 student satellites, and 2 re-entry missions, and take it to an orbit and bring it back, and totally 342 foreign satellites. So that means this is the record from 1963. That is the Paramparik development. It is with our own technology developed by Indians. That is what we should be proud of. This is the one started with 1963 with a sounding rocket. Sounding rocket measures the atmospheric conditions. Whatever experiment you put in the nose cone, it takes to an altitude of 200 to 500 kilometers and it falls back. Why sounding rocket it is called? Your knowledge is sound. You have a sound knowledge. You are sounding the atmosphere to know some parameters. Okay? So that is, it is analogous to that. And first started with Kalam, 1980, a launch vehicle which can put 50 kg satellite into orbit. Later ASLV, 150 kg, and now PSLV, GSLV and Mark III. All three are live and being utilized for satellite launch. And 1993 it started. It can carry either one or multiple satellites of 1700 kg to the Earth orbit or polar orbit. If my satellite weight is 17 kg, how many you can take? You heard that ISRO has taken 100, isn't it? Okay, fine. And GSLV can take 2200 into geosynchronous orbit. You will see what is geosynchronous later. And GSLV can take GSLV Mark. This is Mark II. This is Mark III. It can take up to 4000 kgs. Okay, all three are operational vehicles. From where they are launched? They are launched from Sriharikota. You see this Sriharikota Island. This side is Bay of Bengal. This side you have Nellore at 80 kilometers. This side you have Tirupati at 80 kilometers. This side you have Chennai at 80 kilometers. All three are 80. Okay, and it is a very nice place, and no persons are living here. And you see here, there is an advantage of locating a launch station at equator. Why? You have to tell me now. When you launch eastward, you get the velocity, Earth's velocity added to the launch vehicle. Okay? So that is you see the equator is here. In the equator, how many launch stations are nearby? This is one. And this is French Guiana, Brazil, European Space Agency launch vehicle, launch pad. This is Sharp. So that means we are second. We are actually second best as far as a launch pad near equator is concerned. You are clear what is the advantage of equator. Some people, they don't have such a land near equator. First of all, if you look at it, how many countries are there on equator? I listed here 13 countries. All are small countries. Okay? They may not have, let us say, the space research activities. So that is why some people have come to ocean platforms. People are planning for even ocean platforms to launch rockets. Typically, rocket launch will be like this. It can be a 3-stage vehicle or 2-stage vehicle. Satellite will be integrated on top of the launch vehicle, and it gets covered with a nose cone, so that while traveling in atmosphere, it will not burn up due to heat, and later on, nose cone will be ejected out. You see here. You see here, first stage burns here. At the end of the first stage, it gets separated and lands. At the end of the, let us say, second stage also land. This is the nose cone, you see here. Because you have crossed the atmosphere, satellite is exposed to the atmosphere and the nose cone is separated and it lands. And this is the second stage, and afterwards it is taken into the orbit. This is the final stage, and satellite is separated out. That is how it goes. Okay. Look at this here. What is the velocity required to put a satellite into orbit? See, I have kept a person here. He has thrown something. Of course, you cannot throw this much distance, but it landed here. Why? It doesn't. He has not given enough velocity required to overcome the gravity. Correct? Okay. Then You have to give so much. What is that so much? If you are at 200, you want to keep satellite at 200 kilometers, you have to give 7.8 kilometers per second. Okay? You can see the altitudes here. 500, 7.6, 10,000, 4.9. The geosynchronous satellites at 3 kilometers per second. That's sufficient. So it cancels the gravity. This is the PSL for you, the special photographs, so that you can see one is being moved on the right side, it is being moved onto the launch pad. The first one is the first launch pad. It has got 4 stages. This is the Mark II vehicle. The black one is cryogenic stage. The cryogenic stage is something where the fuels are maintained at minus 200 degrees centigrade, liquid oxygen and liquid hydrogen. Okay? When you want to maintain at minus 200, what type of insulation you require? Thermos flask itself, after 24 hours it gets cooled. Okay? You require good insulation for minus 200 degrees. This is Mark III, which can take 4000 kg. And this is the small satellite launch vehicle. So if somebody says that I have only 50 kg satellite or 500 kg satellite, and can you launch? Why should we use PSLV or something? You can use a small satellite launch vehicle. That is why ISRO has developed a small satellite launch vehicle. The first launch is going to be this year. So the moment the launch takes place, this is the control center. It's like a flying saucer, isn't it? The control center, and how the scientists are located for carrying out the activities in the last minute during launch. And you can see all the displays, what they monitor for public as well as for them. And you have, how many of you seen the live broadcast on 14th of February? PSLV C-52. I saw one hand. But earlier you have seen, not before, yes. It will be similar to this. Okay. When the rocket takes off, you should know where it is, its position, its velocity, whether it is going to in an intended path. If it is not going in intended path, the rocket on board has got something for which, without posing any danger, RSO will take an action, the safety officer. So to know the position and velocity, we have the radars here. This is multi-object tracking radar. This is another wind profiler. This is the camera system. This is the S-band radar. This is the MET instrumentation. In addition to that, we have timing station. So much of network is there, instrumentation. Okay, this is what about the launch complex and the type of launch vehicles. And let us look at the spacecrafts. We have spacecraft for communications, the Earth observation, the scientific spacecrafts, the navigation. There are experimental like you can orbit and return it back. We have small satellites and you have student satellites. Each one has got its own purpose. What are they? What are those applications? Look at this. What's happening here? What is this one? This line is on top of the equator? Roughly? Not roughly, exactly. So, the moment it is on equator, if you keep the satellite at 36,000 kilometers away, the advantage is always it will be seeing the same place on Earth. Why? Because Earth takes 24 hours to go around. This will also take 24 hours. So it appears every time as if it is above you. That is the advantage. This is used for mainly communication. You see this one, pole to pole. They are polar satellites. So the same things are marked here: equatorial orbit, polar orbit. If somebody launches inclined to the equator, it is called inclined orbit. You see here, this is nothing but high elliptical orbit. Some are circular, these are circular, these are elliptical. For some applications you may require elliptical. So highly elliptical, medium elliptical, and low Earth orbits, which are within 500 kilometers to let us say 800 kilometers, they are called low Earth orbits. This is geosynchronous orbit. They are the communication satellites. So that one slide will give you how the orbits are. You see here communication satellites, some names are here, and you have the first one is Apple, and the INSAT DC4A, and the GSAT-9, INSAT-3B, so many are there. What are the applications? Have a look at it. Television broadcasting D2H. How many of you are having D2H? Why? Well, very few hands are shown. Everybody might be having, you may not be knowing that it is DTH.
So that's why nobody is raising.
Direct to home. Okay? And the mobile applications? Yeah. So there are other things called, in case you get into a trouble when you are traveling by a kind of a passenger steamer or whatever it is. If somebody is stuck there, either on earth or sea, anywhere in the globe, search and rescue, many things can be done. And it can be used for disaster management, and it can be used for, let us say, the business communications. It can be used for internet. Many things are there. It can be used for permanent earth observation. Many things are there. So these are all societal applications. These societal applications, what is the advantage of this satellite? Always it will be over you, because it is at 36,000 kilometers. So no need to shift or change from one satellite to the other satellite. You see here, these are for earth observation or remote sensing. What is remote sensing? You know remote. You know remote, already so many remotes are with you. Remote sensing is anything you want to observe not physically going there, remotely from anywhere. This is remotely observed from space. You see here, everybody thinks that, like we talked about the earth moving around the sun. If the sun is moving, what happens? Same is the case when the satellite is moving around the earth. You see here, the satellite is launched, injected here. It made one orbit. By that time, will Earth be at same place? It is rotating. How much it has rotated? It has rotated by this much, you see. It is rotated by this much. So second orbit. So is it possible if you launch a satellite, every time to go over the expected place of yours? It won't. You see here what is happening. So I want to see, let us say here, this particular point every time when it makes the first evolution, second evolution. Is it possible? No, because Earth is rotating in it. So if I say one orbit takes 90 minutes, one orbit takes in 24 hours, how many orbits I get? 16. Okay. So that means near Earth orbit, all satellites make 16 orbits. But using one satellite, can you observe the same place in all the 16 orbits? No. What do you do? Sorry is telling, either you go for 16 satellites. Yes, people are doing like that. Currently, if you have one satellite, if you want to observe Hyderabad, you have to wait till it becomes another pass over Hyderabad. There is no shortcut. To avoid that, people are launching clusters. Some clusters are like bird flying, some clusters are like train, some clusters are with the different orbits. They are like that. So what are the advantages of Earth observation satellites? Before that, we talked about the clusters, Satellites, you have seen the launch vehicle, PSLV everybody remembered, because when I want to under satellite launch, you only told 17 kg into 100, 1700. Okay? That means it can take 700 kg satellite. And Mark 3 I kept 4000. You said 4000 kilometers satellite, 4000 kg satellite it can take. But now satellite sizes are coming down. They are called small satellites. Look at it here. Small satellite, anything, large satellites are anything above 1000 kg. Anything under 500 comes under a small category. Mini are 250 kg satellites. Okay, micro 100 kg. Nano, pico, femto. What is this? 100 grams, nothing I get. I don't even Cadbury chocolate. You are all reading whatever is given there. Okay, but it is possible, sir. See, that is what the technology and the importance of science. Immediately one should get 100 grams, what satellite I get, what observation it can make. Okay? Look at this here. There is a standardization. So if a satellite is of 1 kg, normally they want to call it as 1 U. Like this, 1 cube. How many of you played with Rubik? Oh, all of you. Good, good. So that means, if I make a satellite like this, can I arrange like this? Possible, I can arrange, isn't it? And I can take there and later I can separate them and put wherever I want. And you see here, if I take 12 of them, what is the size? I put a symbol there. Bread 12 slices. Bread slices. So that means people are able to go to at a smaller level to put your experiment, to put your data system, to put your communication and see that it is working. Okay? They are not like elders like me. They are all students. That is why they are asking for students these kind of things. Okay? You see the example, sir. You see here, what is this? What is the size of this? Earlier at least a Cadbury chocolate. Here 18 gram. I don't even see one cashew nut. If you ask if you have cashew nuts, it's possible. And you see here, somebody wants to make a satellite. What do you do? Let us say if somebody, your daddy or somebody orders say furniture from IKEA, you get a big parcel. What do you do at home? You assembly, that gives a, somebody gives a charge for you. Same thing, satellite. You see that everything is available for sale. Buy, assemble and launch. Keep your own experiment. If you think of some experiment, keep your own experiment. Of course, there is a launch cost. I am not talking about that. Okay? So that means you don't assume somebody getting into space research is something you have to get into a job in ISRO or you have to get into a job in some premier institutions. No. There are many people, many universities, many NGOs, they want to conduct experiments because it has come to this level. Plug and fly. It is plug and fly. See, this is one U. I said exactly. Okay? You see here, I said cluster. At a single place, you see, the place chosen is here. If you arrange this in this geometry, how many satellites are visible? 7, 8. So, the geometry somebody has to work out. So, you know the earth rotation, you know orbital height, you know the period of the satellite. In 24 hours, I want to see at least a couple of satellites to be visible. You have to work out a geometry. And you tell me, when you are seeing a GPS, how many satellites are visible to your mobile to get the location? Anybody? Minimum 3. Okay? Minimum 3. And their geometry should be such that 3 sides of a triangle should not be collinear. Then you don't get a solution. Understood? Okay. You get a good triangle. Those 3 satellites also should be such that Yours is a single point here. Assume in space 3 satellites. Okay? You should get all 3 satellites with non-collinear sides. Okay? Fine. I think you are all catching. Okay, these are all these spacecrafts. We have talked about remote sensing, communication, interplanetary we will be seeing later, and small satellites, nano satellites also we have discussed about the sizes. If somebody wants to, we discussed, one orbit, it makes an orbit like this. I have a station here, it like sun rise, it comes from horizon, it goes. So you will be receiving the data. So the data reception and transmission will be like this. If you launch a satellite, if you don't receive a data, it is of no use to you. This is how ground stations work. Okay? And you don't assume that you require this kind of a ground station. Why? Because you are getting a GPS into your mobile with an antenna. Is that antenna visible to you? No. So this is for special purpose with high data rights. Okay? You see the applications about earth observations, You can do bushfire mapping, you can do ocean monitoring, you can do many things, horticulture, forestry, land mass mapping, agriculture produce estimates, many things. Recently, I want to know who has won the Physics Nobel Prize. What purpose? Forgot to report the names. Anybody? Yeah.
So like for a battery, sir, like.
No, earlier, this year. This year, the winner of the Nobel Prize has got the Nobel Prize because using the satellite data, the greenhouse effect model was developed. You must have seen in newspapers, if the poles ice melt, many cities may get into flooding. All those models have been worked out precisely based on the satellite data. Okay? These are all various applications. And the right side is very advanced applications related to the making a special compounds in space at 0 gravity onwards, chemical compounds, to even robotic assemblies, it can be done. And you see here, there are 2 points listed here. Somebody said, if there is an internet, I can get every information. True? Nowadays, parents and children are seeing through only internet. And it has become more useful in your COVID time. All, even friends, families, marriages, functions, all through that. And recently, I heard in newspaper, somebody has arranged a link for witnessing the marriage, and after that, food by Zomato. So, okay, everything is taken care. So it is possible. So, when such a thing is required for you, when you are in deep forests like Himalayas, Amazon forest, no internet is available because currently internet lines are through landlines. Physically you are connecting. In the house Wi-Fi, isn't it? But landline on the earth, is it existing everywhere? No. That is why so many clusters are being proposed by many people. You see here. What is the number here you are able to see? 41,493. Somebody wants to propose a satellite constellation of 41,493. Out of that he got approval for 4,400 and 1740 has already launched. And similarly, one other for, this is SpaceX, this is OneWeb. And similarly, Earth observations also. As I said, If the one satellite is making 16 orbits, 16 times 16 land masses it will see. 16. So he wants to have a cluster. He has launched 150 or 475. That is how things are going on. It is, see, all of you must have seen the Atlas. What is Atlas? That map was made when the book was published. Right now I want to see the Atlas. I have 475 satellites. It is possible. All 475 satellites give you the data, assemble using a software. I will see the Atlas as of now. That is the use. Many things. I have listed only a few because I think I may be exceeding some time. 40 minutes. Okay. Okay, you see this one. The purpose of some of the space activities being done by spacefaring nations is for producing the quality agricultural products. What do you mean by quality agricultural products? People, I know, you will say organic. Okay. The moment organic label is there, that is quality. Morning only I am talking to Paramparik together. See, I want to give an example to you. All of you know pizza. How many of you have eaten? Oh, so many numbers. Why it is so famous, and people say that specification wise, if you take in Hyderabad, Delhi or America or any other countries, the taste is same. Why is it so? So you are knowledgeable, so you are. The thing is, the ingredients, the machine, the algorithm of automatically making a pizza, everything should be made of that particular company. Then only it is called pizza. Otherwise, all other things are derivatives. We will not talk about derivatives. They say, why ingredients? You mean to say wheat powder you don't get here? Why you have to say ingredients only? Because any crop in a particular soil you grow, that particular ingredients, whatever required for the plant to grow, is taken from the soil. So the wheat produced out of that is rich in that. Same seed, you put it in our agricultural research NGRI. It also produces the seed, but only thing is the constituent of the proteins, constituents of the seed are slightly different. Grossly it will change, but slightly different. That may give even taste difference. That is why that company insists, buy ingredients from me, buy the machine from me, buy the recipe from me, you make and sell. That is another business tactics. We will not talk about that. Okay. So when you want to make, it is actually our requirement is next 30 years. The population is going to expected to grow by 2 billions within 30 years. Such a time. As you said, I don't want to take any vegetable filled with pesticides. From that to per acre yield, I want to increase it to whatever maximum possible. Everything put together, you can automate and suggest to the farmer, look, today's atmospheric conditions are like this. Next 10 months are like this, going to be like this. A particular crop is useful to you which will give maximum yield. That is how. This is the next generation crop system which is going to be once again, let us say, the data is given by the space systems. This is the Indian GPS. We have the 7 communication satellites here at 36,000 kilometers away around the equator. It gives the GPS. It has not yet come to the mobile levels. Soon it will come. It is used. The advantage is here is, if the GPS satellites are switched off in the Indian region, which are controlled by different countries, you imagine what will happen when you travel by navigation using foreign satellite GPS. You will be in trouble. So that is why the GPS here. This is the other areas of space application. Here afterwards, when you want to make an experiment, why should I go with the manufacturing of the structure for the satellite, battery, solar panels, telemetry system and computer systems? Everything is a repeat. For example, I will put a floating platform on space 500 kilometers away. I will give slots to you. Everything is there. You just make your satellite without all these things launched and insert into the slot. Automatically data will come to you. Like your International Space Station. ISS, how many of you? International Space Station. Right. So like that, docking, 3D printing and many. Suppose that agriculture related things you want to give information to the farmer, use space data and apply artificial intelligence. Space farming, if somebody is going and staying for 7 days, you don't require to take food. You can do farming there and many other things. But I said somewhere, somebody has listed 49,000 satellites to be launched. Is it not a debris there? Lot of debris. You have to remove it, isn't it? There is a regulation by United Nations what to do with the debris. But the people have started developing debris removal satellites. Okay? There are many applications. Because these applications alone we can talk for a number of hours, so that you can look at it and see what applications it is. क्या है? Which area is this? No, there are two landmarks here. One is here, other is here. So like this, you can get imageries. And today, I don't want to make a mention if something is going on. If you want to monitor what other country is doing, a particular place, whether they are constructing a big building, big arms store or whatever it is, people are finding out in minutes. Okay? Now let us come to we have talked about exploration around the earth. Exploration around the earth. Can you explore moon? Yes. Any experiments were done by ISRO? Yes. Already listed there, isn't it? Okay. And do you want to explore Mars? Yes. Oh, good. Okay. And what for? 5 minutes? What for means either to find out any societal benefit purpose, anything is going to happen, and whether you can go and live there. If you want to talk about the habitable zones in space, so these are the habitable zones. Other places cannot be habitable because of temperature and all other things. If you want to travel to moon, okay, how many days? Which moon is about 3.6 lakh kilometers away. It takes 3 to 4 days, okay, depending on where the moon is. If you want to travel to Mars, You see here, Mars will take 2 years. So because of its distance, okay, if you launch here, it takes 6 months to go and join Mars there. If you want to come back after that, by that time this Mars has moved that side. So once again, I want to come back, I have to wait again here, okay, and come back to Moon. That means anybody who wants to travel, I have to wait for being away from Earth by at least 2.5 years. Travel onward 6 months, return 6 months, you have to wait for one orbit, okay? Anyway, if all of you know about this, yes, this this is a book is written by me in Telugu, all of you can download, okay, freely available, and this is about the Mars experiment, and these are the images of the Mars, the Chandrayaan 2 experiments. What are the experiments that are kept in the satellite, and the Chandrayaan 2 observations. Of course, the lander has not landed. This is a human space program. If you want to take humans to these areas, what kind of development you require, and what kind of suit you want. And recently 52 launched, and it has launched 3 satellites. You see, INS 2D is a mini satellite, Inspire is a micro satellite. That means those structures are also available in India. So you see here satellite, one cyclone photograph is taken with the lightning. You see here, they are all lightnings. Okay. What is this? You heard of this? Yeah. It is such a terrifying volcanic eruption monitored by satellite. You see a city nearby before and after. Okay? And it seems in 24 hours, in 3 days, because of that cloud, it has given nearly 5,90,000 lightning strikes. Such a terrible one. This is about ozone layer, and okay, this is about somebody is doing an experiment where the entire plastic waste can be mapped. How useful that you see. And you see here somebody wants to go to moon, the animation will be this type. Okay. So if it is on Mars, if any of you have got a couple of questions, you can go ahead.
Thank you.
question was, you said that there were satellites which weighed less than 100 grams or just below 1000 grams. But the fuel itself is heavy, right, sir? The fuel required to travel to the orbit. So then how do they manage the weight, sir?
No. It is attached to the launch vehicle. Launch vehicle will take up to 500 kilometers and leave it there. No, you don't require any fuel. It is an omnidirectional antenna.
So it did this.
Yeah.
Yes, sir. Thank you.
Stop.
Sir, if Earth stops, what will happen?
First, when you get out of the bus, what will happen? Obviously, that is going to happen, isn't it? And in addition to that, if Earth starts rotating, you don't see day and night. In about maybe you can calculate, your temperatures will become subnormal in no time, maybe less than a month's time. And later on, suppose if you are not ejected out, and later on, it is very difficult to live.
Thank you, sir.
Yeah.
Can I have?
So I might sound a little irrelevant, but do we also have time travelers?
Yes.
Can you just
See what happens nowadays, the time traveler is something like this. You have seen, you are seeing the light of the sun rays from the sun after how much time? What is the distance from Earth to sun? 150 million. And light travels at what speed? Then how you can see immediately? It takes 8 minutes. You can go and calculate. It takes 8 minutes. If I am seeing a sun now, is it current one?
No, sir.
How many minutes old?
8 minutes.
8 minutes old. Similarly, through Hubble telescope, they are going back and seeing the galaxies 10 light years away, 15 light years away, 1500 light years away. It is the moment time travel is, this is the concept in the observation. The time travel, what you are seeing in movies is different. Where I remember some, in one of the Tamil movies, a particular scene, a fellow will become, let us say, he is going on a street, he go to a watch repairer. What is that movie?
24.
And then why should he wants to come back, and why I should go to that watch shop, I will do something else. Then the scenario differs. Then he enters into some other difficulty. Because of our age, I am forgetting the movie name. I do see movies. Okay.
Thank you so much.
Thank you very much, sir, for the wonderful talk we had. I think you have inspired many students here to be as astronauts, work in space technologies, and even be time travelers. And I'm sure that you have time traveled a little before than most of the students here, and we apologize for the delay for the students to come a little late. But I think you have mastered both space and time, I would suppose, and we would, as this is a festival, we request you to accept our apologies. I would now request Dr. Uday Kumar sir to honor the guest with a memento and showers.
Thank you.
I also request the guest to change the session.
Yeah, I won't take much of your time, but thank you very much, sir. There are two aspects to this whole lecture. One is how much the technology has advanced, and the other message probably you can take is how small you are and how egoistic you behave. Okay, so in the whole universe you are nothing. That is the philosophical aspect of it. So I don't want to bore you. Thank you.
Dr. I request Dr. Arindra sir to further guide the students on the stall.
Okay, dear students, now again, so we have to visit the stalls. 3 schools are here. The left side is Akshara International School, this side is Mamata School, back side is another school is there. So now Akshara International School, batch wise you have to go back to the back door, volunteers take them to the stalls. Only Akshara